Okay, hello everyone, and welcome back. Thanks for listening. Today we're going to talk about combinations. Our objective is to define and count combinations. They're kind of like a permutation, but they're a little different. The essential question is, how do we count the number of possible groups? That's what a combination is. It's a grouping, where order doesn't matter. Just to review, in a permutation now, that was what we talked about yesterday. Order does matter. A permutation is an arrangement, like a listing of some or all objects in a set in a specific order. And here's the formula right here. We talked about it yesterday. And again, one of the examples we talked about for a permutation, this is a permutation. If we were running a race with 6 runners, how many different arrangements are there for the runners to finish first, second, and third, where order does matter? And we found out yesterday it was 120 possible ways to finish first, second, or third. But suppose we're running a race, it's just a qualifying race. It doesn't matter who comes in first, second, or third. We're just taking the top 3 finishers and they move on to the next round. Basically, it's how many groups of 3 can we make choosing from 6 runners. Well, here they are. I listed them right here. There's 20 different ways for the top 3 finishers to qualify and move on to the next race. 20 different groups. Not 120, only 20. Because order doesn't matter. As an example, 1, 2, 3 right here. I'm not arranging that like 1, 3, 2 and 2, 3, 1 and 2, 1, 3. And I'm not arranging all. There are 6 ways to arrange that. But we're not worried about that, okay? Again, this type of counting is called a combination. And here's the formula. It's very similar to the permutation, where it's n factorial on top, and n is how many we're choosing from. The bottom again is n minus r factorial, just like a permutation. But then you also have to divide by the r factorial. All right, because order does not matter. We're just counting the groups. And again, r is how many we're choosing for the group. Again, a combination is a grouping. A permutation is an arrangement. And you can think of a permutation as an ordered combination. You can think of it like that. Again, in a combination, order does not matter. It's just a group. In the permutation, the arrangement, the order, the listing does matter in a permutation. All right, here's example 1 here. How many groups of 3-digit numbers can we write using the digits 1 through 5? And remember when we did this with a permutation, our answer was 60. There were 60 ways to arrange 3 numbers, choosing from 5. But here, there's only 10 ways. They're listed right here. There's only 10 groups of 3 that we can make choosing from 5 numbers. You can check the formula, and sure enough, 10 ways. All right, it's very similar, but again, we divide that. Instead of 60, we're dividing by 3 factorial as well. So we divide by another 6, and we get 10. All right, another example. How many different ways are there to choose a committee of 2 from a list of 8 candidates? And remember when we did this with permutations, it was president and vice president. And our answer was 56 because order mattered. But now our answer is only 28 because order doesn't matter. All right, I'm just selecting 2. So it's half of that. And so you don't have to flip the president and vice president around. We're just choosing 2 from 8. Again, just some more examples, like 7 combo 4. In other words, how many groups of 4 can I make, choosing from 7? 35. And how many groups of 4 can I make here, choosing from 4? Just 1. There's only one combination there. I just choose all 4 of them. All right, how many ways can I choose 1 from 4? Well, there's 4 ways. I choose 1 each time. Oops. And how many ways can I choose 3 from 4? And the answer, again, is 4, because I just take 1 out each time. Okay? Guys, this is the formula, and sometimes it is written in textbooks like this. All right? C and then N comma R, like that. The number of items in the set and the number of items that we're selecting. And sometimes it's kind of written like this. I just want to show you this in case you're presented with that. But we're going to use where you write them both on the bottom. All right, again, this is the formula. And I want to point out a combination. You can think of it like this. It's a permutation, just divided again by r factorial. Because n factorial divided by n minus r factorial, that's a permutation. So you can take the permutation and just divide it by the number of items we're selecting factorial. Again, guys, in a permutation, is the number of ways to arrange something. Order does matter. They're used for lists and arrangements. A combination is the number of ways to choose something. Where order doesn't matter, they're used for groups. Okay, that's it. Thanks for listening.